right, we're going to go ahead and start 3.4. This is the last learning target for Unit 3. So far, I think Unit 3 has been pretty simple, just kind of an extension of Unit 2, and so I think you'll find the same with this learning target. We're going to talk about compound inequalities still, just like 3.3, but now instead of talking about OR inequalities, we're going to be talking about inequalities that connect with the word and. We actually call this, not a union, this is a typo, we actually call this an intersection. So that's what we're going to talk about in this video. So we've got another truth table here. Okay, truth tables kind of help us see how two sets can kind of go together. So let's take a look at our statements here. A dog is a mammal and red is a color. This is our Q information, our P data and our Q data. Okay, so is P true or false? It's true. A dog is a mammal. Is red a color? True. So in order for P and Q to be true and false, they both have to be true. This is different than the last learning target where it was OR, where, okay, if only one was true, then we could put true here. But in this case, they both have to be true. In fact, I'm going to put that up here as and. They both have to be true. The second one, a dog is a mammal, that's true. Red is not a color. That's false. So because the Q is false, because red is not a color is false, then this has to be false because both are not true. The third one, a dog is a fish. That's false. Red is a color. That's true. Well, now we've got them switched around, but they're still not both true, so the intersection is still false. And then the last way the sets can interact is if they're both false. So a dog is a fish is false. Red is not a color. That's false. And of course, that's definitely not an intersection because neither of them are true. Okay. So P and Q is true the only time when both are true. Okay. And we call this kind of relationship an intersection. Okay, and we're going to define that as the overlapping region of a compound. Oh, let me write that a little nicer here. Okay, and so we're going to talk about what these kind of look like here today. So in words, here's what compound and inequalities look like. In words, if I have something like this, and let's take a look at the algebra first, actually, and then we'll go to the words. If I have something like this where it's x is greater than 2, let me zoom in a little bit here if I can get that better. There we go. Okay, so x is greater than 2 and x is less than 6. So we have both of those things are true. Then I can make that into one big inequality using two inequality signs, and it looks like this set, where x is basically in between 2 and 6. That's kind of how we read these. So we take these two separate inequalities, combine it into a compound inequality, where the variable's in the middle, the smaller numbers on the left, and the bigger numbers on the right, and we read that as saying all real numbers greater than 2, and less than 6. So any numbers between 2 and 6. Okay. If we have the lines underneath the symbols, we read it almost the same way, except now x could be 2 or x could be 6. So we read that as all numbers greater than or equal to 2 and less than or equal to 6. Okay. So that's kind of how we read this new notation with this kind of inequality. Now, how do we go about solving an inequality that looks like this? So here's an equation where instead of two separate inequalities, I have this compound inequality. Okay, so how we approach this is we treat it like there's two equal signs. So I kind of draw a line down the middle of these two inequality symbols. And now I'm focusing on getting x by itself like I normally do in an equation. So I'm going to add the 2. But now instead of just adding it to one side, to both sides, I'm going to add it to all three sides. So I put a plus 2 in the middle, I put a plus 2 on the right, and I put a plus 2 on the left. These 2's in the middle cancel out, and I'm just left with x in the middle. On the right, if I do the math, 8 plus 2 gives me 10. And on the left side, 4 plus 2 gives me 6. I bring down my symbols, and now I've got x alone in the middle and my inequality values on the right. Okay, so now I've got this inequality that reads all real numbers greater than or equal to 6, less than or equal to 10. And this is how I want my final answer to be written. If I want to graph this now, if we take a look at the example above, notice that the line is one solid connected line. Compared to 3.3 where we had two lines going opposite directions, now we've got a line that's connected between the two endpoints. So in this case, my two endpoints are 6 and 10, so I need to label this diagram, so this line, number line, I mean. Oh wait, I did this 100% wrong, guys. And you know what? I'm not going to redo my video. I'm just going to go ahead and show you that we all make mistakes. Instead of doing this plus 2, I should have minus the 2. Right? Because this is already plus 2, so I should have done minus 2 on both sides. Okay, so now that's going to give me x is less than or equal to 6 and x is greater than or equal to 2. There we go. Okay, my bad, guys. See, it's easy to make mistakes even on these beginning problems. Okay. All right, so now when I label my number line, I'm going to put a bracket on 2, and I'm going to put another bracket on 6, and I'm just going to connect those two endpoints. Because I'm basically saying that x can be any number along that line. It can be 2, 3, 4, 5, 6. It could be 5.5. It can be any number that's between the two bracket endpoints. Okay. Let's take a look at another example. Let me turn my page. Okay. All right. So, number 2, page 73. See if I can zoom in just a little bit more here. That's better. All right, so I'm going to draw my lines like normal. Now I've got 2x plus 3, which is going to require 2 steps instead of 1. So the first step I'm going to do is I'm going to subtract the 3 on each side. That's going to cancel out the 3's, and I'll now have 2x in the middle, so you bring that down. Bring down your inequality symbols, your less than signs. 9 minus 3 is 6, and negative 5 minus 3 is negative 8. Okay. Now we've got one more step. I have to get x by itself. So to do that, I'm going to divide both sides now by that 2. Sorry, all 3 sides by that 2. So that's going to cancel out the 2's in the middle and leave me with just the x, which is what I want. I'm going to bring down the less than signs. And on the right, 6 divided by 2 is positive 3. And on the left, negative 8 divided by 2 is negative 4. So now I've got my new compound inequality. I'm going to label my number line. Okay, I'm going to put a bracket on negative 4 because I've got the line under there. So I'm going to put the bracket there on negative 4. On the 3, I'm going to put a parentheses because that doesn't have a line under it, so that's a parentheses. And then I'm just going to draw a line connecting the two of them together. Okay. Number 3 is very similar. Number 3, I'm going to start by subtracting the 2 on all 3 sides. I'm going to bring down my 3x, bring down my inequality symbols. 8 minus 2 is 6. Negative 10 minus 2 is negative 12. Then divide everything by 3. I get x is less than or equal to 2 and greater than or equal to negative 4. So I've already numbered this one, which I should have done the first one. So I put a bracket on the, I didn't need to put a line here. Sorry, didn't need to put that. So that's just a less than sign. So I put a parentheses on -4 and a bracket on 2, and I connect the two together. Okay. All right. Now, on your practice, you might see some different examples that aren't just a add over and divide. For example, I'll do a little example over here. So we'll do a separate one here. You might see something like 2x minus 1 over 3 less than or equal to 2, less than or equal to -1. In this case, we have to remember our lesson from fractions in Unit 2 and how we get rid of fractions. So we get rid of fractions by multiplying by the denominator. So I would multiply this by 3, this by 3, and this by 3 to cancel all the denominator out. On the top, I'm sorry, in the middle, I'd be left with just the 2x minus 1. Bring down the symbols. The right becomes 6 and the left becomes -3. And now this becomes just like the other two problems we did. We're going to add the 1, 2x less than or equal to 7 greater than -2, and then we divide by 2. I get x is greater than -1 and less than or equal to 7/2. Okay, I'm not going to give you fractions on this. I just made this problem up. It happened to be a fraction. But the important part is that knowing how to get rid of denominators. Okay, that's going to pop up in this practice and on the test. So keep this example in mind. The last thing that I want to do are some examples of looking at the graph and being able to write down the inequality that's shown. So if we remember, closed circles are the same thing as brackets. So this is like saying this. So if I have a closed circle, it's just like having a bracket. If I have an open circle, it's just like having a parentheses. So when I write these kind of compound inequalities, I'm going to put x in the middle.